Hi friends, welcome back to the channel. If you want to learn machine learning, you might wonder, do I need a lot of math? The answer is yes, but only certain types of math. In this video, I'll show you the essential mathematics you really need to start machine learning. Math is basically the language machine learning thinks in. Models don't understand words, images, or sounds the way humans do. They understand numbers and relationships, and math is what makes that possible. Machine learning is not magic, it's mathematics. Math helps algorithms understand patterns, minimize errors, and make predictions. Let's dive deeper into the concept. The following would be the important mathematics that we need to know before entering into the machine learning. The first one is linear algebra. Linear algebra is the foundation of machine learning. Data in ML is stored as vectors and matrices. Operations like dot products help models calculate predictions. For example, images that stores in the form of matrices of pixel values. Text into vectors. Model parameters by weight matrices. Linear algebra lets models combine features, transform data, scale to thousands or millions of inputs. Without it, you couldn't even store or process real ML data. Let's move to next one. Calculus. Calculus helps machines learn from mistakes. Using derivatives, models adjust their weights to reduce errors. This process is called gradient descent. Learning means reducing error. Models make a prediction. We calculate how wrong it is. Calculus tells us how to change parameters to reduce that error. This is why derivatives, gradients, gradient descent are at the heart of training neural networks. If there is no calculus, means no learning. The next one is probability. Probability plays a crucial role in machine learning because it helps models deal with uncertainty. In the real world, data is rarely perfect or completely predictable. Instead of giving exact answers, machine learning models often make predictions in terms of likelihood or confidence. For example, when an email filtering system analyzes a message, it does not simply say spam or not spam. Instead, it calculates probabilities such as a 90% chance that the email is spam and a 10% chance that it is not. The system then chooses the most likely outcome. Probability also helps models learn from data. During training, algorithms measure how likely their predictions match the actual data. They continuously adjust themselves to increase the probability of correct predictions and reduce errors over time. Another important concept is conditional probability, which tells us how likely something is given certain conditions. This idea is widely used in applications such as medical diagnosis, recommendation systems, and spam detection. One of the most famous tools in probability is Bayes' theorem, which allows models to update their predictions as new information becomes available. This makes machine learning systems smarter and more adaptive. In simple terms, probability gives machine learning models the ability to think in terms of uncertainty, make informed decisions, and improve predictions based on data. Before a machine learning model can learn anything, we first need to analyze the data, and that is where statistics plays a key role. Statistics helps us summarize large amounts of data using simple measures like the mean, median, mode, and variance. These measures tell us about the central tendency of the data and how much the values vary. For example, the average marks of students or the spread of house prices in a city can be understood using statistical concepts. Another important use of statistics in machine learning is understanding data distributions. A distribution shows how data values are spread. One of the most common distributions in machine learning is the normal distribution, also called the bell curve, which appears in many real-world datasets. In the upcoming videos, we will learn in depth of each topic one by one. If you found this video helpful, please like, share, and subscribe.